This is section 13.2 on line integrals, and this is example 6. And we just introduced the idea of the third component z, and so we did a problem in example 5 where we converted everything to t's, and we integrated a line integral that was originally with respect to arc length, so ds. And now if you notice, we're going to do a problem where we're looking at a line integral that's in terms of each of the three differentials, dx, dy, dz. So our main strategy here will be to turn everything into terms of t, just to kind of come up with something that is general. And if you look at our diagram here, we're going to go from 2, 0, 0 to 3, 4, 5. We'll do that as C1, and then we'll do 3, 4, 5 to 3, 4, 0 for C2. So we'll do it in two different parts. In both cases, we're going to convert this path to just a line segment in terms of t, and we'll come up with parametric form for that. So let's get started with C1. So again, we'll look at just this one specific line segment from 2, 0, 0 to 3, 4, 5. And to do this, we're going to need a vector between these points. Remember, our strategy here is to take the end point minus the beginning point. So 3 minus 2 is 1, and 4 minus 0, and 5 minus 0. So we get the vector 1, 4, 5, and then we're going to choose the point 2, 0, 0 to be our starting point. And that way, t is going to be between 0 and 1, which forms the line segment. So for our equations, we have x equal to the x value, which is 2, plus 1 times t, and then y is going to be equal to 0 plus 4t, and z is 0 plus 5t. And then we're also going to need dx, which is going to be dt, and dy, which is equal to 4 dt, and dz, which is equal to 5 dt. So all of our differentials are important. And what we're going to do is we're going to take all of this stuff we just found, and we're just going to do direct substitution into this line integral and evaluate in terms of t. So we have the integral from 0 to 1, and in the original we have y dx. That's going to be instead 4t times, instead of dx, dx is equal to dt, plus z, and z is 5t, and dy is 4 dt, plus x is the quantity 2 plus t, and dz is 5 dt. So again, we're just taking every single element and we're plugging it in based on our parametric form for the line segment. Okay, now what we're going to do is simplify this. So 0 to 1, and we have a 4t, and that's going to give us 20t, and 10, and 5t, and then we have a dt. And that simplifies to the integral 0 to 1 of 29t plus 10 dt. So there's our simplified form. I'll go ahead and pause the video and I'll work out the antiderivative, and then we'll start the second path. Okay, so here we go. This is going to be the value of the line integral for C1. So the first path is going to be 49 over 2. Let's take a look now at the second path. So for our second path, we are going to go from 3, 4, 5 to 3, 4, 0. And since the only thing changing is z, this is going to actually be pretty simple here. Let's go ahead and do the full equation, however, just to make sure it makes some sense. So our vector is going to be 0, 0, negative 5. Our point is going to be the starting point, 3, 4, 5, and t will be between 0 and 1. So we have x equal to 3 plus 0t, so x is 3. Y is equal to 4 plus 0t, so y is 4. We probably could have figured those out. And then z is equal to 5 minus 5t. That gives us dx equal to 0. That's something that should be really obvious because x did not change. So the differential dx and dy are both 0. For z, we have negative 5 dt. So for our line integral, it actually simplifies a great deal because when we're looking at the original line integral, since dx and dy are both 0, what we get is the integral from 0 to 1 of x, which is 3, times dz, which is negative 5 dt. And this is just 0 to 1 of negative 15 dt, and we don't even need to really think about the fundamental theorem too much. That's just going to be negative 15. All right, so what we have then is 49 over 2 and negative 15. So if we're going to integrate the line integral of the original, which is y dx plus z dy plus x dz, and we're going to add it, sorry, that was C1. We're going to add it to the integral for C2, which is negative 15. We get 49 over 2 minus 15, which gives us 19 over 2. All right, so that's example 6. The next video will be on example 7.